Hey everybody, welcome, Ready Set Data, where we cut out in the middle of the broadcast and load back up and try to pretend like nothing happened until I start talking and I just told everybody what happened. So, like I said, Ready Set Data. My name's Anthony Fortner. I'm a data engineer, and with me, as always, the database extraordinaire, Lee Markham. Round of applause! Yay! Okay.
Round of applause. There we go.
That's beautiful. I love it so much. Okay, so what we are going to be doing this time, again, for a little bit of fun, I'm going to be asking Lee questions. For now, I'm sticking to SQL-specific things for the obvious reasons. We tend to stick towards IT topics, specifically things in the data side. Last week, I loaded up a site and asked him interview questions from a person we both frequent for knowledge. It was Brent Ozar site. Don't remember if I mentioned that. We were discussing what we wanted to talk about this time, and Lee, you suggested, let's do that again. Let's do some more. So I found a site that is not a data specific site. And
Okay.
it's not. This is but it's asking questions about. It's supposed to be interview questions. So
Okay.
they just seem very open-ended. And
Sure.
as I told you before the stream, this could be train wreck. But you know what? That's what I'm here for. All right, first question, Mr. Markham. What is SQL? I'm sorry, no. What is SQL?
Oh, you had the question right the first time. The first thing to know about what is SQL is that we don't say what is SQL.
Why not? Let's lead with that. That's the new.
I'm going to make a bunch of enemies from people watching this probably, but so it was originally called or pronounced SQL as far as I understand the history, and it got shortened to the letters SQL, so people started calling it SQL. But nobody, well, I can't say no one. It feels elitist to me. I'll just be totally honest here. It feels elitist to me to refer to SQL as SQL. Maybe I'm wrong about that, but that's my perception.
Mm-hmm.
So anyway, what is SQL? It's structured query language. It's a non-procedural language where you ask a database for information, or you tell it that you want to insert some information, update some information, or delete some information, or you want to create a table or an index or whatever. You tell it the thing you want to do. The database engine figures out how it's going to do it. You don't have to tell the database engine, do this step, do this, then do this. So in that way, that's why in that way, it's not a procedural language. It's not something like C# or that sort of thing.
I take it back. This is not a train wreck. That was a beautiful answer. Yeah, that's actually great. Yeah, that's one of the things that people don't realize, and I think that's one of the things that people struggle with when they are already programmers and then they have to get good at SQL.
We did that just
they
for
want
me.
Yes, they want to procedurally tell the computer what to do, and it doesn't come out right away. You start writing your SQL, select these things. I want these things from here's where I believe the source is. Where some predicate, basically narrow down the information. And then it's fine at first. And then the moment they start having problems, if we're lucky, they look at the plan and the database engine saying, this is how I got you the information. And they start going, no, you shouldn't have done that. You should have done this. You should have done that. And they get frustrated. They can get frustrated because they're used to telling the computer what to do. And in the database, and well, in most database engines, especially if you're paying a lot of money for them or they're really big, there's a lot of time and energy and talent, aka money, pumped into building out that query engine, and it's making decisions. So that was actually a good answer. The one thing I will disagree with you about, and I'm actually not doing this to be
Okay.
trolly. Oh, that's fun too. I actually think saying it must be SQL and dogging on people who say SQL is elitist. So it's interesting. I am not being trolly. Like
No,
you
I
said
can see
that, and
that.
I was like, that's interesting because I actually feel the other way. I feel like around here in the Midwest, and honestly, actually in the U.S., here in the America, uh, we say SQL all the time. When people say SQL, they don't. But then, and I'm not an expert on humans, I barely understand myself. But when I listen to people talk from other countries, there's a lot of SQL. And I'm not going to say all of them, but I hear a
Okay.
lot. And so I think whoever you trained with, whoever you learned with, how they say it is the way it goes.
That's fair.
That being said, if you're around, like we're in the Midwest, right? We both are in the Midwest. If you're around here, probably all over the United States, although I'm not an expert, you probably want to get used to saying sequel in like interviews and stuff like that because for the reasons we both said. Like we both said the same thing but backwards, right? There's a lot of people who say sequel. So you want to say sequel, and then once you have the job, you can make them mad by saying SQL or GIF versus GIF or data versus data, and then you can have those arguments. It'll be fun.
Yes.
Are we
Yeah.
good?
Yeah, we're good. I mean that makes sense. I mean you pick up what you were taught, what you were first exposed to. So yeah, it's totally fine. Yeah. So that's why I have a preference toward saying sequel.
Yeah, no, 100% fine. I thought it was an interesting topic to talk about
Yeah, for sure.
because you jumped right in that. Second question on this not actually database specific site giving us interview questions. I'm going to paraphrase it because I don't think the wording is really good.
Okay.
When did SQL appear?
When did I'm sorry, I missed part of the question. When did what appear?
When did, like I said, this is very open ended. When did SQL appear?
After the first one, obviously.
Well,
Um,
what do you think about the prequel?
so yeah, we don't want to go there. So structured query language relational databases, as far as I understand, started with a man named is it CF Cod? I think we're talking the 60s and early 70s.
Yeah, 70s.
And I think it started with IBM with SQL, and that's where the language came from. Is what I remember from the bit of history I've read some years ago.
So SQL. Now I'm cheating. I'm googling it right because we want to put
Yeah.
some facts out there on the interwebs. SQL was initially developed at IBM. That's kind of cool. By Donald D. Chamberlain and Raymond F. Boyce after learning about the relational model from Edward F. Codd
Okay.
in the early 1970s.
I
So I
think
don't
a
hate that
pretty
as
good
anything.
answer.
Yeah, I don't think that I don't hate that as when I read it, I
Mm-hmm.
splitched. When I read it, I thought this is a really weird open-ended question, and my first thought was I didn't like this as an interview question. This seems like a really big curveball. Maybe curveballs are okay, and it got you talking, and you're like, oh, and actually, yeah, it was like the '70s and COD and some other things. So
Yeah.
maybe I don't hate this as an interview question because, like, yeah, for a junior who's just like, I just did SQL to make sure I can complete the tasks that you can complete. That's okay, but you can find out the people who like have read a lot into it and like really wanted to get down with. Some people do read about relational theory.
Yes, for
Super
sure.
interesting.
I
Okay.
love Liam's very correct answer, which was after World War II. That is correct.
Yes, I lost my chat box. Thank you for reminding me that the chat was on. Boo-boo. Anthony has lead questions. This might just become a thing. Okay, cool. So I don't hate that question. I thought I was going to make fun of it, but I mean,
I think it's
cool.
a fair question. It's a conversation starter. You can kind of tell if the person has read anything about the history, if they know the major players that got things going, that
Yeah,
sort of thing.
I worry that if you hit somebody with a question who's a junior too early with that, they will be like, "How am I supposed to know that?" Like, you get if you get a good answer. If I got the answer I got from you, if I was interviewing you, like, oh, that's a great answer, cool. But I'm afraid of, like, if you were a junior and you didn't give me that answer, then that would negatively affect you, mentally.
Yeah, it could be a confidence killer.
No,
I could see that where he was like,
yeah,
I don't know, why would you even ask me that? Is something going on in your brain, and now you're kind of like distracted. So,
yeah. Um, let's see what happens to this one. Okay, let's see if you can change your mind about this question. What are the usages of SQL? I guess what they mean is, how is SQL used?
well, I mean, first and foremost, SQL is used to create a database, which is just the container. I'm not going to say it that way. You almost got me. So SQL is used first and foremost. It can be used to create a database, which is an intelligent container that for information that will provide you with constraints, so that you don't put junk into it, so you don't complain later when you get junk out. Which is the other thing that SQL is used for, is querying the data. Get out of the system what has been put in there, typically by an application. Right now, especially BI of various flavors is super important. Machine learning to predict if people buy these 3 products, they might also want this one, so we should show it to them on the website. That kind of thing. Yeah, that's what SQL is used for.
Yeah, definitely. The notes here says it's kind of like a bullet point list, and I want to comment on that, but I'll read a couple
Sure.
of them. It's like execute queries into data against the database. We try that again. Execute queries against the database. Retrieve data from the database. Insert records into database. Update, and I'm going to stop there. And then a couple about creating things.
Yeah.
For the record, I like your answer, but I'm like giving people tips because they ever talk to me later. I don't like when I interview somebody and I ask them a question and I get a bullet point list. No, it's just no. It's like now I have no idea if you know the thing or you just are good at memorizing the thing.
Yeah.
Just talk to me.
Yeah.
But anyway,
Yeah, that's a good point.
Mm-hmm. Yeah, I like what you're saying. You were making a comment. I'm supposed to not cover my face. You made a comment earlier, like you started saying it's a container, and you didn't want to say that. And I think the reason why you were dodging that was because you've heard people say, "Hey, the database is just a container. Shove data in there, pull data out." And I think both of us agree that the constraints and the rules that you can give the database are part of what makes it so powerful. You know,
Yeah.
I don't think
Otherwise, you should just put your data in an Excel spreadsheet and be done with it.
Oh yeah, a highly concurrent Excel data. I can't do it. A highly concurrent Excel sheet. I don't know. I just can't do it. Whatever.
Yeah, this is I'm going to get on a soapbox for a second. So this is the thing. This is the sticking point I have with folks who are like who will say what I almost said. The database is just a dumb container for data. We just put stuff in and we get stuff out, kind of like you were talking about. If it's just that, then how come it costs so much? If you just want to put data in it and get data out, just use an Excel spreadsheet. Oh, you want concurrency. You want 5, 10 people, 10,000 people to be able to access it at the same time. Well, maybe it's not just a dumb container then.
Right.
Maybe there are actually some rules
sheet.
behind it.
Yes.
That keep your data safe and in a consistent state that is usable for you to continue to put data in and get decent data out of it. Yeah, sorry. Rant is over.
Apologize for. No, so on continuing that subject, because I think that's really what I get at with these little sessions where I just ask you questions, to get us talking to see where it takes us. This is where this is taking me. I've had those conversations, and I want just to play devil's advocate. I know that's a thing with me. There are situations where you do just want a container of data. You really do just want to put data in there so you can get it out later, or put it in there so other things can get access to it quickly. That's okay. But you need to know when you just need a dumb cache and when you need an intelligent relational database. And what I would argue you don't want is to use a relational database engine like SQL Server or Oracle, Postgres, whatnot. You don't want to use those as a dump store because you're paying a lot of money, even for the free ones. You're paying a lot of money and effort and time to use those as basically a data bucket when you should be using something that is good at that. Because let's be honest, if you did your data storing in something like Redis or something that is just going to hold that data in RAM and give it back to you sick fast, it's going to break some speed records. SQL Server's not necessarily going to be able to compete with that because it's good at that one thing. SQL Server brings so much more to the table, and it'll do a lot more faster than the dump store. So,
yeah, for sure.
But I think we're in agreement.
I think so.
I'm going to ask this question the way it's worded to see what you say. This is another one I think it's worded weird. What are the subsets of SQL? And if you're lost, I said up front, I don't like the wording.
So the first thing that comes to mind is the fact that when I say SQL, what I really mean is Microsoft Transact SQL or T-SQL.
Mm-hmm. Yep.
Which is a dialect of SQL that is proprietary to Microsoft, meaning that it has special reserved words that only work when you're querying a Microsoft SQL Server database. So in contrast to that, you have ANSI SQL, which is based on the ANSI standards, which I think have different numbers for different years that they were approved. And if you use ANSI SQL, then it will work across the board. My understanding, not that I've tried this, but the idea behind ANSI SQL is to have a common denominator that works across the board with a multitude of relational database engines. So if you use that, then you could port your database to any number of relational engines, and it should just keep working. That's my answer, and I'm sticking to it.
I think you should. So that's not what this was asking, but yeah, there's definitely different dialects of SQL. And if you know ANSI SQL, you can pretty much do a lot in any RDMS. But there are slight differences.
Yeah. So what did this question? What was it getting at?
So I'm gonna try to word the question differently and see what happens.
Okay.
If you were to divide the SQL language into 4 separate languages, into 4 separate subsets to get different things done, what would those 4 subsets be?
Well, this makes me think of the 4 parts of SQL Server. And I still don't think that's what the thing is after, the question. Yeah, the way you just worded it made me think of the database engine, integration services, analysis services, and reporting services. But I doubt that that's what the question is after.
Yeah, it's basically asking for DDL, DML, DCL, TCL. Data definition language.
Oh, great.
Data manipulation language. Data control language and transaction control language. So, transaction control language. I don't know how many different words there are in that language, commit, rollback, set, save point. Like,
Oh, okay. That's
but
not how I would try to find out if the person knew that create table was DDL, and I don't. Okay,
yeah, okay, moving on. Like I said,
fair enough.
yeah. Um, the next couple questions are really about that. I don't know. I don't want to ask those, so I'm gonna skip ahead. Oh, here's an intro to database question right here. What are tables and fields?
So a table is an entity that is stored within that database. You have the field is a particular cell. Like if you think of a Excel spreadsheet and you think of a cell in an Excel spreadsheet, that's an intersection of a column and a row. The table should be made up of one entity. So if we're talking about customers, for example, it should only have information about customers, not sales, not phone records or phone numbers, and that sort of thing. The table has attributes, which are also called columns, and those attributes could be things like a first name attribute or first name column, last name. You might have, other information that identifies a customer within a table entity. There you have it.
Beautiful answer. Love it. And you went into a little bit of theory there because I don't think a lot of times when people answer the question, what is a table? They go, it should be, because it's not. A table is all the other things, but what it should be is, one idea, one like students or customers or addresses. Yeah.
Yeah.
You join them to connect them.
Right.
Too often people try to put all the info into one table and they wonder why they have problems afterwards. So I like it. What is a primary key? And I'm looking forward to this one because every one of these has like a short answer, but you give good answers. So, what, Mr. Lee, is a primary key?
So first and foremost, by default, when you make a clustering key in SQL Server, you also end up with the primary key is a clustered key by default in SQL Server. If you don't want it to be clustered, then you have to specifically say primary key non-clustered. So the idea is the primary key creates uniqueness. It is a way to uniquely identify a row. It is the first rule of normalization, as we talked about, that came about from COD. We mentioned him earlier when we had the history question about what is SQL.
Mm-hmm. Yep.
So the primary key, you need a unique way to identify each row so that the database has a way to find the information that you're asking it to retrieve or that you're asking it to update or delete. If you don't create a primary key, then you, in SQL Server at least, you end up using row identifiers to find things because it has to have some unique way to find data. Since the primary key is also clustered by default in SQL Server, I'll talk a little bit about that. Clustering keys should be narrow, meaning if you're using long strings to create a key, you're doing it wrong. They should be ever increasing, which also means if you're using strings to create your key, you're doing it wrong. Could there be unique existing values within your table that you could use? Yes. Those absolutely could be there, but you want a way to organize the data that's easy for SQL Server to search. And searching long strings to find rows is the opposite of easy. So
yeah. Okay, so I feel like what you kind of touched on there was the difference between a natural key and a surrogate key. Do you have a hard preference between the two then? I don't mean 100% of the time. I just mean like, but you have a definite preference for one versus the other?
I do. I lean heavily toward a surrogate key that is an identity property because that means you get an integer value. Usually you start at 1. Usually you go up. So and you use int or big int, depending on how many rows you're going to have, to indicate what the range of values is. I like that because I think it's so hard to find good natural keys. Customers or people designing things will often look at their data and they'll find 2 strings, for example, and they'll use that for a key because they realize that makes the row unique. But then that hurts SQL Server because it has to sort strings in order to do inserts, updates, and deletes if you've used that as your clustered primary key. And that's just not the way to do it. It's if you take 2 fields that are 50 characters long and you combine them to create a key, well, now SQL Server has to sort those to keep the data in some sort of logical order. You're introducing page splits like crazy, which is or can be a performance problem. If you use something like an integer with an identity property, it's ever increasing, it's small. SQL Server can find a number. It can find 1, 2, 3 faster than it can find Anthony Fortner.
I like it. I also have that same leaning. The general rule in my environment is you do the surrogate key auto incrementing, starting at 1, working your way up, and then but it's at 100%. Like if you really feel that there's a natural key that's better than some reason, you basically go into it like, I'm going to do a surrogate key unless I want to have a conversation with a group of people and explain why I want the natural key. And that's pretty much the stance I take, and that works out because you have to really want to like prove your point in order to have that conversation, so it becomes rare. Yeah, so I agree with all of that. Let's see here, and then I'm gonna skip a couple, and I think we'll do one more unless you have some kind of inspiration. What is the difference between a primary key and a unique key?
So I think you picked this because it ties into the question you just asked me. So a primary key by default in SQL Server is going to be clustered, which means it's going to be ordered by that piece of information. And you can only have one clustering key. The data can only be ordered in one way. If you create a unique key, you have not ordered the data of the table. You have just said these 2, 3, 4 values, whatever columns or attributes you've chosen, have to create a unique combination. So you might do this for something like an email and a customer ID. They have to be unique because you only want a customer to have one email address. I don't know. I'm kind of making something up, but I have worked with systems where email was a unique index because they didn't want multiples. So
yeah, they had a business rule. Hey, we don't want 2 people have the same email, or 2 people shouldn't have the same desk location, right? The desk location isn't the primary key. It isn't how this table is supposed to be delineated, but there is a rule, and they want the table to enforce that rule. And as we talked about earlier, this is a situation where the database is really good at just handling that for you.
It is, yes.
Cool. I appreciate you letting me run these questions. It went better than I expected. I honestly thought these were so junior, so open-ended, really.
Mm-hmm.
Those first couple. that I didn't know where it was going to go, but I like where it went. So I really appreciate that. Awesome. So thanks everybody for joining us here. Ready Set Data. I'm Anthony Fortner, data engineer. I look forward to seeing you all on all the different places that you find us. And with me is Lee Markham, database extraordinaire, database administrator. All right. Bye, everybody.
Bye.